Now we're going to use Laplace transform again to find Laplace transform of y second. We can use the definition and we can integrate between 0 and infinity y second e to minus st dt, and taking the limit as x goes to infinity of y second e minus st dt. And assuming that the y second has exponential order, we can do integration by part twice to get the result. But we are not gonna do this work here. We're gonna use what we have seen in from the Laplace of y prime. So we know that Laplace of y prime is s Laplace of y minus y of 0. We're gonna use this result here to find Laplace of y second by doing this way. So it's gonna be Laplace of prime of the y prime. Okay, so here when we apply this result here, we're gonna get s Laplace of y prime minus y prime of 0. So we are using we are applying it here to y prime. We are applying this result that gets for y prime, and we are applying it here. Okay, you can think of y prime as some f. Okay, so here it's s l y prime minus y prime 0. And now we're gonna use this result here. So we have s ly. So I'm using this one here minus y of 0 minus y prime of 0. Okay, now if I extend everything, or I expand everything, I'll get s squared ly minus s y of 0 minus y prime of 0. And I can write it in this manner: s squared Laplace of y minus s y 0 minus plus y prime of 0. And this is the Laplace second, Laplace of y second. Notice that Laplace of y prime is given by s Laplace of y minus y of 0. This order of the derivative is always the power of s that we multiply by Laplace of y. Okay, and we're gonna see that if we try and write this one for y3, we're gonna see that we can use here this y second, and we're gonna have s3. Okay, and we can see that we can write this one in the following manner if we want to use it here, using this kind of logic. So L3, so the power is gonna be, the order of the derivative is gonna be the power in s. So it's gonna be s3 ly minus, okay, note here that we're gonna have in this case, if we expand, okay, the derivative doesn't have a power, and in this case it's gonna be the second one plus s y prime of 0 plus s squared y of 0. Okay, so we can write it in general, but here we need to notice something. Okay, the power of the derivative is the power that gets to the s that we multiply by the Laplace of y. And here we start from the derivative from 0, 1, 2. We don't get into 3. Okay, if we want to do the 4, L, y, we use this notation. So it's going to be s to the power 4 ly minus, here I'm gonna do y3 of 0 plus s y second of 0 plus s squared y prime of 0 plus s3 y of 0. And I hope that you see the result that we can get in general. Okay, by just using this one here, we can get all this result here. Okay, we're gonna need these ones because we wanna transform something like this. Okay, so using the linearity, we can get Laplace of y prime minus y is Laplace of 1, which is 1 over s. And here using linearity, we get Laplace of y prime minus Laplace of y is 1 over s. And we're going to keep working. That's why we need this one. If we have y second or y third, we need to have this one. Okay? And in general, we can get the result that we're going to prove using induction in one of the videos. Thank you.